Hello dear friends, in this discussion we are going to discuss something about single-phase transformers. So the guiding question says, the equivalent impedance referred to the primary of a 2300/230 volts 500 kVA single-phase transformer is Z equal to 0.2 plus the reactance is 0.6. So the imaginary part is 0.6, the real part is 0.2, which comprises of the resistance. So calculate the percentage voltage regression when the transformer delivers the rated capacity at 0.8 power factor, lagging at rated secondary voltage. So find the efficiency also of the transformer at this condition, given that the core losses at rated voltage are 2 kilowatts. So this is losses. So let's find the solution for this problem. Now, we are told that this is referred to the primary. So meaning the R or 1 is equal to 0.2 ohms and X or 1 or the inductive reactance referred to the primary side is 0.6 ohms. What is the rating of the transformer? The rating is 500 kVA. Then what else do we have? We are also provided that the power factor is 0.8, and we are supposed to analyze this problem at full load. Then also the copper losses, full load copper losses, this is at full load is equal to 2 kilowatts. What else? The secondary the primary secondary voltage ratio is 2,300 volts and 230 volts. Now, what do we need to know to calculate the percentage voltage regression? We know that the voltage regression is always equal to voltage at, for example, if we are referring this to the primary, voltage at no load, so V1, so minus the full load voltage divided by the full load voltage, we multiply by 100 to just make it percentage. So that is the percentage voltage regression. But we also know that if I get the no load voltage minus the full load voltage, I'm supposed to get the full load current I1 or I01. I multiply it by the real component of the impedance referred to the primary, that is R01, times cos phi, which is of course the power factor of the load, plus XO1 sine phi. Everything divided by the full load voltage, which we are taking to be usually the E1. So multiply. Okay, so that is this particular component when this is not there. So what does that mean? So what we are going to do is to look for this. So we know I1, this one, is equal to the rating of the transformer in kVA divided by, usually divided by the primary voltage. So 2300. So if I do that, 500 exponent 3 divided by 2300, I have current equivalent to 17.39 amps. So this is the full load primary winding current. And we already know that cos phi is equal to 0.8. So what is sine phi? Sine phi is going to be sine of cos arc of 0.8, and this is 0.6. So what does that mean? That means that the percentage voltage regulation is going to be 217.39 into the resistance is known as 0.2. Then we multiply by 0.8, then plus 0.6, which is the inductive reactance referred to the primary side. I will multiply it by this sine phi, which is 0.6 also. Okay, then we are dividing it by 2300. We multiply by 100. So this is going to be times 0.2 times 0.8, then plus 0.6 times 0.6. We divide everything by 2300. We multiply by 100, and this gives us the percentage voltage regulation as 4.91%. So that is the percentage voltage regulation at this condition. Then the transformer efficiency. So the transformer efficiency is part B. So transformer efficiency at power factor 0.8 and rated voltage. So that means we are going to look for the copper losses. So PCU losses must equal to I squared R. So this is going, since it is a single phase transformer, we shall maintain that. So this is going to be 217.39 squared multiplied by resistance referred to the primary, which is RO01, RO1, which is 0.2. Okay, you can check on the question, it is given as 0.2. So this is going to be 217.39 squared times 0.2. So we find that if I divide it by 1,000, I have this as 9.4517 kilowatts. Now, the iron losses are equal to, we are told that it is 2 kilowatts. When you check here in the question, it is given as 2 kilowatts. So what next? Our task is now to look for the percentage efficiency of the transformer, which is going to be the kVA rating times the power factor times the load X divided by the kVA rating times the power factor times the load X plus losses. So multiply by 100, and this is going to be, we know that the kVA rating is 500 times 10 power 3, but since we have converted everything to kilowatts, we can leave the rating in kVA. So we multiply by the power factor which is given to us as 0.8. This is 0.8 times the load X, which is equal to 1 because we are talking about full load, divided by 5,000 times 0.8 times 1 plus now 9.45, we said, for 517, then plus 2 kilowatts. So times 100, and this is giving us, so 500 times 0.8. So we are getting 97.222%. So that's how we can do this problem. See you in the next lecture.